Hello ladies and gentlemen, and welcome back to Prospect Charter School's Algebra 1 course. Today we're going to be going over section 2.7, Rates, Ratios, and Proportions. So with anything with math, we need to know our definitions before we can move forward with the fun numbers stuff. So let's go over these definitions. The definition between ratio and proportion, while similar, are not quite the same, and rates are also very, very different. So let's start with a ratio. A ratio, not to be confused with Horatio, who is an awesome character in Shakespeare's Hamlet. A ratio is a comparison of two quantities by division. Two quantities by division. An example of a ratio would be like when you're cooking rice. You know that for every cup of rice, you need 2 cups of water. So you'd have 1 cup of rice for 2 cups of water, which we just call 1/2, or 1/2. So a ratio is basically a fraction. That's it. It's just a fraction. A really easy fraction. Fractions are friends. Decimals are demons. We should be fine with fractions. So we know what a ratio is now. Now what's the difference between a ratio and a proportion? Because they are different. A lot of people use ratio and proportion interchangeably, but they're actually incorrect. Because a proportion is a statement that two ratios are equivalent or equal. So a proportion is actually not the same thing as a ratio. A proportion actually requires ratios. It requires 2 ratios, while a ratio is just that. It's a comparison of 2 things through division or a fraction. So for an example, 1 cup of rice for 2 cups of water. Well, what happens if I have 5 cups of rice? Well, then I would need 10 cups of water. So a proportion has an equal sign, while a ratio is just a fraction. That's the easiest way to remember the difference between the two. So what good are ratios and proportions? We really do. We see them pretty much every day. Anytime that you cook from a recipe book, you see ratios and proportions. So for an example, let's say that we have a recipe that feeds a normal-sized family of 4. But you have friends coming over. So you no longer have 4 people that you need. You need to feed a family of 6. So what we would do is we would start with the ratios of all the things that we need for the family of 4. So let's say that the recipe for the family of 4 requires 2 pounds of hamburger. If you're vegan, feel free to use the vegan hamburger. 1 pound of broccoli, because it is one of the most awesome foods on the planet, and 2 cups of rice. Now we want to convert that for our family of 6. So what we do is we turn each one of these into a ratio. 2 pounds of hamburger per 4 family members. 1 pound of broccoli per 4 family members. And 2 cups of rice per 4 family members. And then for the family of 6, we keep the same ratios, but we need a proportion. We don't know how many pounds of hamburger that we need for a family of 6, but we do know that we need 2 pounds for a family of 4. We don't know how many we need for a family of 6, but we do know that we need 1 pound of broccoli for a family of 4. We don't know how much rice we need for a family of 6, but we do know that we need 2 cups of rice for a family of 4. Now, the nice thing about this is that because these two fractions are equivalent, I just have to do it once, and then I'm done. So when I'm changing my recipes, I would use this formula, this setup. This is a pretty typical setup where you're using a proportion to figure things out using ratios. You see this all the time in cooking. You see this all the time when you're doing construction. You see it everywhere, really. I can't really think of anything that you wouldn't use it in. You use it in teaching for how many chairs you need, how much paper you need, etc. You use it for cars and how much fuel you're using. It's everywhere, so it's a really nice technique to have down. So let's start with the first one. Let's say that we have 2 over 4 is equal to x over 6. We need to figure out what our x is. To do that, we have a couple of techniques. The easiest to remember is to just cross multiply. So note how the multiplication only occurs across an equal sign, hence it's cross multiply. And make sure that you put the things on the right side. You notice how I have an arrow pointing to the top left from the bottom right. That means this is going to be on the left-hand side of my equal sign. So I get 6 times 2. So I'd say 2 times 6, and then equals, note the arrow, 4 times x, which gives me 4x. And then it's just going back to the previous things that we've been doing in previous sections. 2 times 6 is 12. Divide both sides by 4, and we get 3 is equal to x. So for our family of 6, we need 3 pounds of hamburger for the family of 6, and we will need 3 cups of rice for the family of 6 because it's the same proportion. You don't need to do it a second time. That means that all that's left is figuring out the broccoli. Now with the broccoli, we have 1 over 4 is equal to x over 6. If we cross multiply, 6 times 1 is 6, 4 times x is x. We get 6 is equal to 4x. Divide both sides by 4. And we have x by itself, but now we've got 6 over 4. They're both even, so I can reduce. 6 divided by 2 is 3. 4 divided by 2 is 2. So x is really 3 halves. So I need 3 halves of a pound of broccoli, which means about 1.5 pounds. Alright, so that's the cool trick for ratios, is about cross multiplication and paying attention to which side it is. Make sure that you can, at first, until you get it down, you draw these arrows so that you know which side of the equal sign they go on, because that actually is important later on. Okay, let's move on to the next one. Next up we have something called rates, and this is something that you guys see a lot. So a rate is a ratio of 2 quantities with different units. 2 quantities with different units. So an example of a rate. How about pay? Pay is kind of a rate, right? When you go to one workplace, they say, yeah, we'll pay you $17 per hour. Are dollars and hours the same thing? Well, no, they aren't. But this is a rate, right? It's a comparison of 2 things, dollars and hours. What about fuel economy for cars? You get miles per gallon. Let's see, what other rates do we see out of there? Oh, speed. Speed is usually measured in miles per hour or kilometers per hour, depending on where you're from. Same with miles per gallon, could be measured in kilometers per liter. And dollars per hour could be whatever currency that your current location uses. Fortunately, we all use hours, which is pretty awesome. So a rate is a ratio of two quantities with different units. This leads us to one of the most powerful tools in science, and that is dimensional analysis. I like to call dimensional analysis the train track method. The reason why I call it the train track method is because it looks like a whole bunch of train tracks. What dimensional analysis does, is it allows us to convert from one type of unit to another. For an example, if we are used to seeing things in miles per gallon, but we're given it in kilometers per liter, we need to figure out how we can convert between them. We need to figure out how many kilometers per liter is the same thing in miles per gallon, or vice versa. So to do that, we first need some conversions. So to get conversions, you would usually be given a conversion sheet, and then that conversion sheet would help you figure everything out. So here's our conversion sheet. We're given that there are 1.6 kilometers in 1 mile. We are given that there are 3.85 liters per gallon. And now we are going to be given that if we get a car that has a really good gas mileage at 42 miles per gallon, how do we convert that into kilometers per liter for our friends who are in Europe? Well, to do that, we start making a bunch of train tracks. Now you'll note that I have a horizontal line all the way through, and then I draw some vertical lines as kind of a separator between different sections. And what these are each one of these is a unit conversion. I'm going to be converting a single unit in each one of these, and I will do a whole bunch of unit conversions to get from the units that I'm in, miles per gallon, into the units that I want to be in, which is kilometers per liter. So how do I go about doing this? Well, to do it, I first start looking at my unit on top. My unit on top is miles, and when I want to convert, I want that unit to go away. I want to be left with kilometers per liter. This is my final destination on this one. So the first thing I want to eliminate is my miles. I want to turn my miles into kilometers. How do I do that? Well, I'm given a ratio. I'm given a ratio of 1.6 kilometers per mile. So what I would do is I would make sure that my miles cancel with the miles here. So I put the miles underneath, which means that my kilometers would go on top. Then I plug in the numbers. I get 1.6 kilometers for every 1 mile. To double check, I look at my units. Miles cancel with miles, and I'm left with kilometers, which is what I want at the end anyway. So I'm done with that unit. The next unit would be gallons. I have gallons on the bottom here, but I also have gallons on the bottom for my little ratio. So how do I get this ratio to cancel with those gallons? Well, you always want to be on the opposite side of the horizontal line to make it cancel. So I know that my gallons have to be up here so that they will cancel with the gallons over on my original unit, which means that my liters are going to have to be on the bottom. And then I plug in the numbers. For every 1 gallon, there are 3.85 liters. Do I have liters on the bottom now? Well, let's find out. Gallons cancel with gallons. I am left with liters. I want liters on the bottom. Check. We're good to go. So it looks like I only needed to do 2 unit conversions, so I just erase the extras. And then I do the arithmetic. Now to do the arithmetic, we pull out our handy dandy calculator. Say hello, calculator. The calculator actually can't say hello. I'm sorry. Anyway, so what I would do is all the things on the top represent multiply. All the things on the bottom represent divide. So I just go through one piece at a time. I start with my 42 because that's the number on the top left. And then I divide by the number on the bottom. Well, the number on the bottom is kind of non-existent with a 1, so I'd say divided by 1 equals. Okay, now I'm done with that one. On to the next one, I got the 1.6 on top and the 1 on the bottom. So I take this line, multiply by 1.6, and then I divide by the 1 on the bottom. On the next one, multiply by the 1 that's on top, the 1 gallon on top, and then divide by the 3.85 liters on the bottom. And I get 17.454545. I'm going to round that up to 17.5. So I would say I get 17.5 kilometers per liter. So when we're going through, let's go ahead and erase our units here so we can see it a little bit better. After I've made sure that my units work out, I'm just looking at the numbers. And I start with the top left. I divide when I go down, and then I multiply when I go up. So I divide by 1, multiply by 1.6. Divide by 1, multiply by 1. Divide by 3.85, and I'm done. That's as far as I need to go. So multiply across the top, divide across the bottom. Let's see another example of this. Let's say for a moment that we have a seahorse. And it rears up and says, "Nay, I am not a horse, I am a fish." And I say, okay. And what we're going to do is we're going to look at it and we're going to say that we have this seahorse swims at 52.68 feet per hour. 52.86 feet per hour swim speed. So what is that in inches per minute? Let's say for a moment that we're doing some kind of weird analysis thing and we need to convert our feet per hour into inches per minute. Well, to do that, again, we start with the unit that's given. We have 52.86 feet per hour. And now we need to convert feet into inches and hour into minutes, because our last destination should be inches per minute. So we need a few conversion things. One thing is that for every 12 inches, you get 1 foot. And for every 60 minutes, you get 1 hour. So here are our conversions that we are going to use. Now, how do we do that over here? Well, to do that, we start with whichever unit we want to eliminate first. I'm going to eliminate feet first because they're usually really stinky. So because I want to get rid of the stinky feet, I would use this ratio because it's the only one that actually has feet in it. Because the feet over on the left on the given are on top, I want my feet that from my conversion to be on the bottom. So I put 1 foot on the bottom and then 12 inches on the top. Now I need to do a second conversion. Well, actually I should probably check to make sure my inches and feet and everything are working out nicely. Feet and feet cancel. I am left with inches, which is what I want, so I am good to go. All right. Next up, we got the 60 minutes per hour. So if I put in 60 minutes per hour like this, does something bad happen? Well, remember, to cancel they have to be across from each other on this horizontal line. So do my hours and hours cancel? The answer to that question is no. No, they don't. So if they don't cancel, I need to make sure that they do, which means that my ratio is upside down. I need to put hours on top and minutes on the bottom. Then I double check. Hours will cancel with hours. I will be left with minutes, which is the unit that I want, so I'm good to go. Now I do the arithmetic. Remember, we start at the top and we go down, up, etc., until we reach our final destination at the end. So pulling out my handy dandy calculator, clear this out. I have 52.86 divided by 1 hour times 12 inches divided by 1 foot times 1 hour divided by 60 minutes. And I get 10.572. So my inches per minute would be at 10.572 inches per minute. And we box our answer. That's it. That's how difficult it is. Just do it one piece at a time. Use your calculator. It's okay to use your calculator. And use your railroad tracks. You will find later on, especially once you get into like chemistry, physics, etc., that having the railroad track method down will make all of those subjects so much easier. One of the reasons why I do so well in physics is because I know how to do this. This is one of the main key points in physics, especially when you're converting between metric and imperial.